This is a continuation of my series on electromagnetism. In this video, I will be taking an in-depth look at a Y-Y or star-star connected transformer. You can find this topic in my course entitled Electrical Three-Phase Power Transformer Fundamentals. You can access this and my other courses in my Stan Store at this web address. In this video, I'm going to take a closer look at the Y-Y connected transformer. The primary and secondary phase-to-phase voltage relationship are both the same with respect to their respective phase-to-neutral voltages. The primary phase-to-phase voltage leads the primary phase-to-neutral voltage by 30 degrees, and the magnitude is √3 bigger. Similarly, the secondary phase-to-phase leads the secondary phase-to-neutral by 30 degrees, and the magnitude is √3 bigger. The turns ratio of this transformer is given by the phase-to-neutral primary over the phase-to-neutral secondary voltages. Because the phase relationship, the line-to-neutral voltages can be written in terms of the line-to-line voltage, which, as you can see, can also describe the turns ratio. When analyzing these transformer connections, for the most part, if not all of the time, we are considering the system to be balanced. That is, we have balanced voltages that are equal in magnitude and 120 degrees apart. So if we wanted to develop the per phase analysis of a transformer that was Y-Y connected, the per phase equivalent of this transformer would look like this. We would be using the line to neutral voltages both for the primary and secondary. And if we were to convert the secondary line to neutral voltage to the primary line to neutral voltage, we would have to multiply by the turns ratio, which is designated as A here. And if there was current flowing in this single phase equivalent, then the ratios of the line currents would be the inverse of the turns ratio. In other words, if we wanted to calculate the secondary line current, we'd have to multiply by the turns ratio. And it goes without saying that there are two voltage levels to be looking at, a primary and a secondary voltage levels, and we can describe them in terms of the line to neutral voltages. And if we adopted these two voltages as the base values when considering a per unit equivalent circuit, then our per unit equivalent circuit would look like this, which essentially is just two wires, neglecting, of course, the turns ratio of the transformer because we're dealing in per unit values here now. We have used the base voltages, and we can either use line to neutral base voltages or line to line base voltages. However, the per unit magnitudes of the voltages are the same because we're dealing in per unit values now, as are the per unit values for the current. In this slide, I made a quick reference to the per unit equivalent circuit. And in each one of the configurations as we go through them, I will be referring to a per unit equivalent circuit. If this seems very mysterious to you, I'd encourage you to have a look at the course that we offer on per unit analysis, because per unit analysis is a whole other course in itself. However, I will make this reference if you don't have an interest in per unit values, and you can disregard the last little portion referred to. However, as I said, I would encourage you to have a look at the course on per unit analysis, and that will remove the mystery of the per unit equivalent circuit. In this short video, I want to continue to reference three vendors that happen to be three of the most popular power supply vendors on the market today. I will be providing links to their sites, which if you use, you'll be able to take advantage of a reduction in their cost price. But rest assured, they are quality products. First off is EcoFlow. I have introduced you to this vendor earlier, and it is still one of the vendors that are at the top of my list. They have an exciting line of various power supplies, which you can view and recognize a price reduction by going to this website. Now remember that the address is case sensitive.
Next on the list is Anker. Their range of products are similar, but they also cater to the smaller output devices that are very portable. Again, you can take advantage of some of the sales by going to this web address. And finally, there is Bluetti, who also caters to the small output devices as well as having the larger standby power supplies. You can view their full range of products and take advantage of their price reductions by going to this web address.